chapter. All right, so completing the square. A couple of different parts that can go into this. So we're going to kind of build our way up to the actual completing the square. But one of them is using the square root property. Now we've done that before in some ways. You take the square root of both sides, you get an answer. But here, what you're going to notice is, the left side of your equation in 1 through 4 are both perfect square trinomials. Now, if you don't notice that right away, again, just always look at your first and last terms. If they're both perfect squares, typically that's going to get you into a situation where you can make a perfect square binomial out of this. So here's how this works. If I were to do regular factoring and not think about this for a minute, what are two numbers that would multiply to 81 but add up to negative 18? Yeah, negative 9 and negative 9, which would just give me x minus 9 squared. So if I got to that point with my factoring, and that'll happen on each one of these, then you'd go, oh, well now it looks sort of like what I've been doing. Take the square root of both sides, because again, I don't want that squared there. I need to figure out what x is going to be. So x minus 9, remember, it's a quadratic. There are two answers. So don't forget your plus minus when you're doing your square root step. And in this case, since it was a perfect square and broke right down for me, I'd have 9 plus or minus 7. But again, we always simplify when we get to this point. We don't just leave things that way. So 9 plus 7 is 16. 9 minus 7 is 2. Bless you. And I've got my two solutions for my problem. So whenever we're doing these, again, just kind of do in your head what your two numbers would be to factor here. You're like, well, 10 times 10 is 100, and there's a plus in the middle. Look for those little patterns. And then again, just start breaking it down. Whenever we get that squared term, there we go. That basically gets rid of my squared. And if some of you can start looking at these and figuring out what the answer is without that last step, that's fine. The only caution I say to that is a lot of times people will forget, oh yeah, that sign changes, and they'll do 10 plus 8, 10 minus 8, and they'll be a little bit off. So just something to be careful of if you decide to go that route. But either route that we go, we need to make sure, thank you, we get down to those final two answers in their simplified forms. It even goes when my first value isn't just x squared. Again, 4 is still a perfect square, so is 25. It just means when I make my perfect square binomial, it just means, well, what do I square to get 4? 2. What do I square to get 1? 1. Plus in the middle. And then I just run the same process. But again, the only thing you're going to want to watch for, besides the fact that I did not give you enough room to work with here, is going to be in a situation like this, you're like, ooh, now what am I supposed to do? So normally you just minus the 1 over, and for most of these, you've been done at that point. But in this case, I still have a 2 in front of my x. So I still have to divide. And I still, again, I don't have any radicals, so I still need to simplify each one of these. So for instance here, negative 1 plus 4 would be 3. So I'd have 3 over 2. If you went to a decimal, I won't complain too much. Negative 1 minus 4 is negative 5 over 2. So I even can get fractional answers in with these. It's not like I can't, just because they're perfect squares. And then same on the last one. I just look, I go, okay, what do I square to get 25x squared? That'd be 5x. I square 4 to get 16, and again, there's a plus in the middle. But there's one thing we haven't had to do yet that we get to do in this last one. All right, so 5x plus 4. Ooh, I get to break down the radical this time. What's the square root of 28 break down to? 4 and 7. And the square root of 4 is 2 square root of 7. And the whole process just continues basically like it did in number 3. I'm going to subtract my 4 over. And then divide both sides by 5. Now this time, that doesn't really break up. The 7 doesn't break down. It's not perfect. I can get that as an answer. But let's just say, and it didn't happen in this one, but it could. Let's say this would have ended up being a number like 4 or 8 or something like that. If all 3 terms have a number that's not under the radical, that's divisible by the same number, you do have to reduce that. So that's something you want to think about when you're doing problems like this. But whenever it says solve by using the square root property, that's what we mean. Get it into its binomial form, square root it, and then go about what you normally would. That's kind of a step that gets along further when we get to the actual completing the square process. But there's one step we get to before this, which is finding what's called our C value. So here's how this is going to work. Whenever we're doing these, there's a value we need to be able to add to these to make them like the perfect square trinomials that we had up above. Well, how do I get there? Each time it's going to be taking b, dividing it by 2, or halving it, and then squaring it. So in other words, when I get here, my b value, my value in front of x, is 6. So I'm going to do 6 divided by 2, which is 3, and then I'm going to square it. That would be the value that I would add to this to make it a perfect square trinomial. Because then, when I go to put it in its factored form, same number that multiplies to 9 and adds to 6 is 3. And here's the even cooler thing. When you get forward and we start getting some nasty numbers that work, this value right here is whatever b divided by 2 is every time. So when you do your first step and you do b divided by 2, in this case it was 3, that's the number that's going to go in here. Positive, negative, fraction, doesn't matter. Makes you have to think less, especially if it ends up being a fraction, which we will hit here in a minute. But that's just going to be my b divided by 2 number every time. So it's kind of cool that the way that kind of works out. So with any of these, again, and make sure the sign goes with you, that value divided by 2, and then square it. Whatever number comes out every time is going to be a positive number, a number that gets added. If you get a negative, it means you forgot the parentheses when you were squaring it. So don't forget those. And then again, just use the shortcut. What did I get when I did b divided by 2? I got negative 8. Pop that in there. There's my perfect square binomial. My perfect squared binomial. So basically between these two, you're doing the whole completing the square process. Then it gets a little nasty. You're like, ooh, 5. Stay away from the decimals. You'll see why when we get into this. You're like, well, 5 divided by 2 doesn't simplify anymore. That's true. I can still square it though. And remember, when you're squaring a fraction, you're really just squaring the numerator and you're squaring the denominator separately. So 5 squared is 25. 2 squared is 4. That's what's going to go in here. And here's where we're thankful for the shortcut. Because if we had to sit here and figure out what multiplies to 25 over 4 and adds to 5, that wouldn't be too much fun. But we know how to shortcut this. It's just x. When I did my b divided by 2, it was 5 halves. So if I were to FOIL out x plus 5 halves squared, I'd get this back. But again, we don't have to do all the thinking with this as long as we remember what the pattern is. And that's going to be true every time. Negative 9, yeah, negative 9 divided by 2 gets me a decimal. Well, okay then, I'll just square it. And again, you're squaring the entire quantity. You will never get a negative number out of this if you're doing things correctly. And when I go to do my binomial, again, just steal whatever b divided by 2 is. And you'll have your squared binomial. Again, not too shabby. So now, we're going to put the whole thing together. The whole completing the square process, which is basically what we've done in the first 2 sections. The biggest thing to remember here, of course, is step 1. Your x squared coefficient has to be 1. If it isn't, you have to divide all of your terms by whatever that coefficient is in front of x squared to make it that way. We'll get to some of those in a minute. Now, I don't know if we're going to need to add the blanks. We'll add the blanks the first time, and then we'll kind of go from there. So here's what we're going to do. First things first. Write the equation in the form x squared plus bx. In other words, and I'm just going to number my steps the first couple of times here. If you don't have an x, you are going away. You have to move to the other side of the equation. Once my x's have been isolated, now I'm going to, at least for this first time, add blanks to each side. And what am I going to add? I'm going to do exactly what we just did in the last part. I'm going to take my b term, I'm going to divide it by 2, and I'm going to square it. And that value is going to get added to both sides of the equation. Now, I'm going to do it using colors if you want to with a blank so you can kind of see why you did this at a later time. So notice, by adding the 36 to both sides, I haven't changed the value of the equation at all. I've done the same thing to both sides. I've kept balance. But now I can start doing some of the stuff I was doing up above. For instance, taking this and turning it into its binomial square form. And again, if it's one that I can't remember off the top of my head, just remember it's whatever value my b divided by 2 was, which is positive 6. And now it should look familiar as to what we were doing in sections before, where we were solving using square roots. I have this binomial term that's squared. I will square root it. I will remember that it's plus minus because it's a quadratic, and quadratics have 2 answers. But I also remember that 32 breaks down. And we always want the simplest answer, of course. So let's see. 4 square root of 2. And my last step will be to bring that 6 over. But remember, you have to do the opposite to bring it over. And it can't break through this plus minus barrier that's there, separating our radical. And that gets me to the exact solutions. Now, am I going to ask for exact most of the time? Yes. Because, well, it's exact. Mathematically, that's the best way to go. However, I also want you to get used to dealing with these with the calculator to get some approximates, because then when we get to application problems, we're not running into other issues. So, we'll take a moment here. And we're going to have to do these separately. There's not a quick fix on how to do it all at once here. So I will do my pluser here first. And again, we're rounding to the nearest hundredth. So in this case, that would be negative 34 hundredths, because the 3 won't allow me to round up. And then I'm just going to take the exact same thing, except I'm going to do minus with that. So looks like negative 11.66. Okay. So those would be my approximate solutions to the nearest hundredth, but that would be my exact. And I believe we put on here for the assignment, we're just going to go for exact on everything that isn't a story problem. So that's how we're going to work these. And again, I won't force you into doing this for every single one here, because that could get a little tedious. So we'll take a look at 10, and then we'll see how we're feeling here. But the steps are always the same. Make sure it's plain old x squared. Your coefficient is 1. It is. Step 2, isolate your x terms. So in this case, by subtracting the 6 to the other side. Step 3 is to take my b term, divide it by 2, square it. Again, how much side work you show or don't show is up to you, but sometimes just seeing that can kind of slow things down enough that you don't do something silly. My left side's always going to be a perfect square binomial, so I'll get it to my binomial square form, which again, I can either factor this or I can just look at my b divided by 2. Square root it. If the radical doesn't break down, that's okay. But if it does, you better. And then add my 3 over. That gets me my exact answer. And then again, we'll just make sure that we get our two approximate solutions of 4.73 and 1.27. And just to mention, sometimes they'll be nice. Like number 11, they even did step 2 for you. It's not like you got to bring the 5 over and then bring it back. If your x terms are already isolated, you just go to step 3 and continue with it. But again, sometimes we won't get things that turn out quite as nice as these. You're like, 10 was nice? Well, maybe not exactly. But when we get to the back here, to exact solutions we will go. Same concept. Nice to us on the first step. X's are isolated. So take my b value, divide it by 2, and square it. Make sure that 25 gets added to both sides, not just the side where you're making your perfect square trinomial. Once I get there, again, I just look and I say, okay, my b divided by 2 was a -5. Get that guy in here. Square root it. Looking good. Ooh, 12 breaks down. Don't forget those things. If you want to wait till the end to break down your radical, I guess you could, but I normally do it when I think of it, otherwise I forget. And then add my 5 over. And again, adding my 5 over does not change my 2 radical 3. It's still going to stay the same way. 5 just gets to hang out on the same side. So you're like, okay, we've had some that break down. We've had some that don't break down. What else could you possibly be able to throw at us? Well, let's do one more up here. Not so nice this time. We got to move the 45 to the other side. Okay. So again, bless you, b divided by 2, square it. So that's what I'm going to add to both sides. This time, life gets a little more interesting. Still can get my binomial term. My b divided by 2 is a -6. But for our first time today, we now have a negative number to play with. So remember, when you take your square root, okay, square and square root, wham, that's fine. What do I have to do to deal with the negative? Take the I out. So here, I'd have I square root of 9, but I know that's going to be 3i. So not only do I have to remember the plus minus with it being a quadratic, but I got to remember, oh yeah, square root of 9 would be 3i. And then I just add my 6 over. 6 plus or minus 3i. And if the radical still would have been there, I just had I square root of whatever it happens to be. She's like, okay, not bad. I, okay, break down a radical, all right. All right, so here comes the big one. What do we do when we solve when the leading coefficient isn't 1? We haven't had any of those yet. So like what we were talking about on the other side, whatever your coefficient is in front of your x squared is what every term has to be divided by. And technically I'm dividing the 0 by 2, but we already know what that's going to be. So I'm like, okay, x squared plus u 7/2 x, and I'm going to subtract that 5/2 over because it's got to get out of the way anyway. And yes, keep leaving them as fractions. That's actually going to make this easier. Like easier. Eesh. All right, reminder times. Especially when it gets to be fractions here. Reminder, dividing by 2 equals multiplying something by a half. So here, for instance, when my b value is 7/2 and I need to divide it by 2, it's just like multiplying by 1/2. So my b value divided by 2 is going to be 7/4. I just did 7/2 times 1/2. And since that doesn't clean up nicely, I leave it that way and square it. So the 49/16 is what I got to add to both sides. Looks ugly, not going to be ugly at all to work with because we know all of the good tricks. Because now instead of having to factor what multiplies to 49/16 and adds up to 7/2, we can amaze people and say, yeah, we know that off the top of our head, it's 7/4. Oh yeah, because that's what b divided by 2 was. Just remember that little pattern and that side becomes easy. This side, now that's not quite as much fun. If you're good with your fractions, which I'm assuming most of you are, you just know that, well, I multiply 2 times 8 to get to 16. So this is really -40 because, well, that's what -5 times 8 is. So -40 plus 49 would be 9. Now, if that's not your strength, if that's one of the places where you're like, yeah, it's that, no, what you just did doesn't quite work for me as well, you always do have the option, if you need to go back to the calculator, keep your fractions in parentheses, and just use math enter, okay? And you can always get back to here. But this is the nice thing about leaving it as a fraction and not going to the decimals. When I go to square root it, so x plus 7/4 equals plus minus, you take the square root of each number instead of trying to take it for the whole thing. The square root of 9 is 3. The square root of 16 is 4. And basically what I can do when I subtract the 7/4 over is I have -7/4 plus or minus 3/4. And again, I want to split that and get the actual 2 solutions for it, of course. So I got -7/4 plus 3/4 would be -4/4, which is -1. -7/4 minus 3/4 is -10/4, which would reduce to -5/2. So again, keep life simple on this. Don't drive yourself crazy trying to go into decimal mode, because all it's going to do is drive you crazy. Now, are they all quite that bad? No. That's probably one of the worst ones there is. But again, anytime you see that number in front of x squared, we're going to divide everything by that number, even when it creates a fraction. Then again, whatever that b value is, divide it by 2. Oops, doesn't go in nice. That's okay. I'll just square each one, and that's what I'm going to add to each side. The ones with the values in front normally don't start off real nice, but as we saw in 15, they can clean up pretty nice for us. And if some of you get to a point that you can go straight to the binomial form, again, that's fine. Just be cautious. Again, I don't have to think about this because I'm just going to use my b divided by 2. That would be 4, so that's going to be 14 plus 9 is 23. Again, or I can use the calculator if need be. What's that? Oh, gee, the calculator's in the way. I got to remember, I physically don't see it. I forget about it. So I square root it. Now, the 23 doesn't break down right away. That's okay. But the 4 does. You can have a radical where part does and part doesn't as far as breaking down. Still nice, though, because I have a common denominator. Just want to show you this. When I minus the 3/2, you absolutely can keep writing these as 2 separate fractions, but if you happen to get a problem sometime and you look in the back of the book, it may be written slightly differently. Since you have a common denominator, sometimes they may be written like that, just to put over one fraction. They're equivalent. So if you put either of those as your solution, you're absolutely fine with that. So nothing too bad to work with. And it's just like the rest. It's just the one step at the beginning, kind of getting you a kickstart. Last thing. Because again, we've got all these different forms. We've been doing everything in standard form. Well, now what happens if they want me to move it into vertex form? Well, first we got to remember what vertex form even is. And those are the ones, of course, where we can pull the vertex straight from the equation, because my center is just going to be at HK. So we're still going to complete the square for these, but it's going to look a little bit different in form than when we did it before. We're not going to isolate, at least not physically by moving things, isolate my x terms. Here's what I'm going to do instead. I'm still going to do my b divided by 2 and square it. Okay, that's 16 though. Here's how I'm going to do it. I'm going to put one of them on my side with the y. And then on the other side, I'm going to isolate my x's, but I'm going to do it by using parentheses. And that 16 is going to go in with them. So it's the same process, except now I'm going to have something else on my side here with my perfect square trinomial. Nothing's going to happen on the left here yet. But this is my perfect square trinomial, where again I take my b divided by 2 to complete it. And you're like, ooh, these are kind of starting to look similar. All I got to do now is take this and say, okay, let's minus that 16 over. That's now in vertex form. And my vertex, or my center point, I probably should have called this V instead of that. I apologize. I went into circle form instead of vertex form, but they still set up this way. So now I'm going to have 4, negative 5. Why did I go into circle form? I'm a silly man. What a silly man. This would be the form if I was looking for a circle. Is there a mention of a circle anywhere in here? No. Silly, silly man. So when I'm doing ones like this, again, I'm just going to keep taking whatever my b value is, divide it by 2, square that, and whatever that value is, I'm going to add it to my y side, and I'm going to blend it in with my isolated x terms. Get my isolated x's into their binomial form, again, by looking at my b divided by 2, and minus my 4 over. And then I can get my vertex again. The opposite of -2 is 2. Keep my 4, and I've got my vertex. And again, like it mentions down at the bottom of the page, and this guy here would be homework check A number 2. Because from our 5-3 notes on 272 to 75, that was our first one, so this is number 2. Leave the answers in exact form, which again means leave the radicals. You don't need to go to the decimals, except if you get up into a couple of the application problems. Then going to a decimal is fine. But otherwise, radicals are good, because I know the directions say round them, and it's like, ugh. Any questions?